All right, let's talk about usage of nomograph to find the CR. So giving this formula, FH is equal to Fn times CR over PR. So FH represents the life factor in hours. All right, Fn is the speed factor in RPM. All right, the shaft rotating speed. CR is the same basic dynamic loading you need to calculate and compare to catalog. PR will be your dynamic equivalent bearing load, which is your factory loading. Okay, so use this if it's stated or required by the question. That means nomograph. If not, we will try to use the equation because it's more accurate compared to you reading from the nomograph. But of course, using nomograph will be easier and quicker. All right, the value of Fn and Fh can be found from the nomograph chart, which later referring to appendix. For a given live rating of L10H, all right, you need to be given the hours and the speed. So if you want to, after you complete this example, you can go back to example 2 and 3 questions to use the nomograph to obtain the CR and see whether it's easier and faster. All right, so if you go to your appendix A3 page, this where you will see A3 page. I think it should be A3 page A3-1, if I'm not wrong. You can refer to the appendix. Okay, give you some time to go to that page. All right, so it should be the uh, first page of your bearing catalog, appendix A3. So what you will see will be 4 lines, right? 4 lines with various numbers. So do take note that it's divided into 2 parts. Okay, left hand side nomograph is for ball bearing, right hand side is for roller bearing. Please, you must refer to a right chart, all right, ball or roller. So in this case, if it's ball bearing, then given that revolution per minute and the L10H, you can read through and get your Fn and Fh. Same thing goes to your roller bearings. Okay, given the revolution per minute and the L10H numbers in the questions, all these must be provided by the questions, and you can refer to this nomograph and get the Fn and Fh respectively. So you must read carefully. Later when we do the example, you understand why we try not to use nomograph because the accuracy of reading. All right, so now using this example, okay, a deep groove ball bearing, okay, ball bearing is required to carry a radial load of 2000 Newton. All right, so it's FR only, there's no FA, radial load, with the shaft rotating at 4000 RPM. So it gave you the revolution, good. The bearing is required to have a life of 10,000 hours. All right, select the minimum size that state the bearing number. Sorry, select the minimum size and state the bearing number. So we have 3 different ball diameter, 40, 50, and 60. Okay, we need to select based on all this loading. So I need to find my FH and Fn. So I have my PR, where my PR is equal to FR 2000. So given N is 4000 RPM, L10H is 10,000 hours. If you go to your appendix 3 nomograph page, go to left hand column, that's where you see a ball bearing. Yes, we have question stated a ball bearing, so go to ball bearing column. So you do see, let's tackle one by one. Left hand side is Fn, so it's revolution per minute. So at 4000, if you go down to the revolution per minute, you look for 4000, look carefully. Okay, don't go to the wrong one. This is 40,000, this is 4000. Okay, look carefully. So 4000, and you read, it should give you of about 0.203. Okay, you can try. How do I get 0.203? What you need to do is there are various divisions between 0.2 to 0.22. So if you look at it, you divide this into half, the portion here with 0.21. Then you further divide it down if you can, and you should get some will read as 0.204, some will read 0.205. That is the reason why we say nomograph is easy, faster, but then again, the accuracy may not be there because of the interpretation of the reading. So we take it as 0.203, and we solve the Fn. So I want to look at my FH, L10H. My L10H is 10,000 hours. So if it's 10,000 hours, you move down, you look for 10,000. And yes, this happens to be coincide with one of the division, make life easy for everybody. And 2.5, 1, 2, 3, 4, and 3. So 2.5, 2.6, 2.7. So you'll get 2.7. Okay, you see a 2.5, so 2.5 to 3, there are total 4 division. So it tells you it's 6, 7, 8, 9, and 3. So 2.7 will be the answer for FH. So we need to calculate our CR. So you convert it. CR is equal to PR, FH over FN. You know my PR, you know my FN and FH. You punch in the variables, you get 26,600 or 26.6 kilonewton. So this is your minimum CR you want for your factory layout. Okay, your factory layout is 2000 Newton, radial load 4000 RPM, and given 40, 50, 60 mm bore diameter. So we want to go and compare the catalog of 40, 50, 60 bore diameter and choose a suitable bearing for this CR. Okay, so let's move. So referring to the ball bearing deep groove catalog A3-2 if I'm not wrong. All right, so you look for 40, 50, and 60. Okay, so this is a question say that I want you to choose the bearing of 40 mm diameter, 50 and 60. And my calculated CR is 26,600 from the previous calculation using nomograph. So I tackle 40 first. My calculated CR is 26,600. Definitely only can choose 31,500 because it is the only bearing that can withstand the 26,600 CR. So the bearing for 40 mm with 6308, and you look at it is how do I know 08, because 08 tells me times 5 give me 40. So it's a deep groove ball bearing 6. 3 will be the duty factors. Okay, 3 should be heavy, right? All right, and then 08 times 5, 40. Then if I want 50, I look for 26,600. Then of course I can choose 27, I can choose 47. Of course, most of the time we choose the closest to it because this is the need. You of course can purchase 6310, but it's just that you are spending more money. So from the catalog, 6210 will be my selection. So 62 will be 1010, right? You times 5 is 50 mm. So you can see that this is the last two digits that tells you the ball bearing. Only 00 to 01, 02, 03. You have to read through the tables. If not, the rest you can straight multiply by 5. All right, 04 will be multiplied by 5. So 60, compare downwards. Yes, I have 40.5 kilonewton on 63. So I can choose both. But of course, I choose the closest 40, which is 6212. That's the answer. 6212 ball bearing for 60. 12 times 5 is 60. Yeah. So that's how easy we can select the bearing based on the calculated CR. All right. All right. So this is the summary of the calculation steps. Same question. It's the same question from the previous example, exactly the same. It's just that this display shows you the steps to calculate and obtain the answer, which we choose 6308 for 40 mm, 6210 for 50 mm, 60 mm will be 6212, where the catalog CR is 31.5, 27, and 40.5 respectively. Right? So calculated CR is 26,600. So you fulfill. So these are the summaries steps for the example. Okay. So please familiarize yourself how to obtain your Fn and Fh value based on the given RPM and hours. Read from the nomograph, then using this formula to find your calculated CR. life make easy for us because the FR there's only one loading, radial loading, and as you can directly uh, find your PR is equal to your FR. Things will be very different if you have an Excel loading. You will complicate the calculation by extra few steps to determine your PR. But there are alternate methods I mentioned. If the questions did not stipulate that you need to use normal graph, my advice to you is please use the equation. Okay, use the equation where you can find your calculated CR also. If you don't believe me, you can punch in using this equation and find your CR because your L10H, your N, RPM, your PR. So you need to find your CR. You just calculate and refer to the same catalog. You will get the same. In fact, you can calculate. It should be about 26,600. It should be that amount. Okay. Please go and do your calculation if you're keen to find out. Okay, we have completed the nomograph introduction. Next, we will talk about what happens when you have Excel loading together with your radial loading.